The next area of security that we're focusing on is security for data. Exactly how do we go about making sure that data on a Windows 10 box is secure? Well, usually in the realm of data security, we're talking about what? Permissions and possibly some encryption. And so we've already covered permissions, talked about NTFS permissions and shared folder permissions, and those are the primary mechanism through which we can secure access to files and folders. But we can take it a step further. And taking it a step further would be using some form of encryption. Encryption, of course, is a process that turns plain text into an unreadable ciphertext that's only decryptable if you have the correct information, the key. And so by doing that, you can ensure that only authorized users are able to access the data. NTFS permissions can be thwarted. I mean, it's difficult to do. You'd have to get to the system and have physical access to it and be able to boot it into another operating system like a Linux distro on a flash drive or DVD. And to be sure, Microsoft has taken a ton of steps with the whole secure boot process to make sure that that can't happen. But still, encryption is something that we potentially will want to do. Okay, so it is an extra step to increase the security of the data. And we haven't talked about the encryption options yet in Windows 10, and so that's what we're going to do here. So the first encryption option in Windows 10 has actually been around since Windows 2000. This is an age-old one, and I've sometimes wondered if Microsoft will ever stop talking about it, but there it is right in the objectives for this exam. So here we go again. EFS, the encrypting file system, tried and true. It is a mechanism that goes beyond typical access controls and utilizes cryptographic methods using both public and private key encryption. Public and private key encryption. Now, private key encryption is also called symmetric encryption, and that just means that the same key is used to both encrypt and decrypt the data. Public key encryption, on the other hand, is also called asymmetric encryption, and that means that there's a pair of keys, a public and a private, and that those keys together encrypt and decrypt. Generally speaking, the private key will encrypt and the public key will decrypt, but it could be the other way around. It just depends on the particular scenario and how we're using the encryption. So cryptography is really just the science of the study of encryption and decryption using ciphers, which are mathematical algorithms to turn plain text into ciphertext. It's a huge subject. If you're interested, there are some great books on it. If you're not interested, there are some great paperweights for your bookshelf. No, seriously, but there are really long books about this whole process because it goes way back. I mean, people have been encrypting information for millennium, so trying to sell secrets and trying to pass coded information. That's all this is. That's all cryptography is coming up with a code. Only these codes are being used through 64-bit high-powered computers that are capable of doing millions more than what a normal human would be capable of doing, and so therefore it's gotten very complex. But it all comes down to math. All comes down to algorithms, and just coding messages, essentially. Okay, so a standard cipher is going to turn it into a text called ciphertext, and assuming that you have the right key, then you can turn it back into plain text. You do have another kind of encryption. It's referred to as one-way encryption or simply hashing. A hashing algorithm encrypts a value, creates a hash, aka a message digest, just a few different names that get used, but it's not intended to, or you are unable to convert that back into the original data. All right, so you might question, well, why would I do that? Well, hashes are not for confidentiality. Hashes are for data integrity. And so IPsec, for instance, which we talked about with the firewall, it does digital signing and encryption. The encryption is to make sure that the data is confidential and it can only be decrypted by an authorized party, the other computer. But the hashing is a digital signature. All it does is it takes the message, runs it through a hashing algorithm, and then produces a result. Well, on the other end, the same thing can occur, and the two results should be exactly the same. If the message is unchanged and the same algorithm is used, then the digest, the hash, are going to be the same. You alter anything in the message, and the digest is going to be completely different. So that's essentially, in a simplistic explanation, that's how hashing algorithms work. So we're not spending much time on hashing algorithms. I'm just mentioning them because that's a concept in cryptography, and it's one-way encryption. With EFS, we're talking about a style of encryption that is reversible. So I can encrypt, and then if I'm an authorized user, I can decrypt the data. It's confidential because it's only accessible to authorized users. EFS is simply a part of the NTFS file system. It's, as I said, been around since Windows 2000. NTFS was originally introduced with Windows NT, of course, but EFS was a later addition. But it's simply just a function of the file system. It's a checkbox that you can go in and check to encrypt a file or a folder and all of its contents. One of the first features that's always mentioned is that EFS is transparent. Well, it's not transparent in that you don't actually have to say you want to encrypt a file, but and it's not transparent in that you can't see that the file's encrypted. What's transparent is the decryption of it if you're the authorized user. So when you double-click a file, behind the scenes, it's applying the encryption key and then allowing you to open the file, okay? But you do have to have the appropriate cryptographic keys in order to decrypt files. And those keys are going to be stored in digital certificates, okay? And here's another place where EFS is very easy to use. You know, this is one of the problems with encryption. The key is not a key like your car keys. It's not even a key like a little ID card. It's not a physical thing. The key is a mathematical key, and it needs to be stored somewhere. And so it's always stored, encryption keys are stored on certificates. Okay? If you think of the web server that you connect to via SSL to do any sort of e-commerce on the internet, that server has a certificate. And you can view the certificate, and you see the little lock, or whatever it happens to be in the browser that you're using, but you can open up the certificate and see, okay, so that's storing that identity of that computer that you're connecting to, but it's also storing keys. Encryption keys that are used as a part of that communication session. Anytime we use encryption, we need certificates. And as I said, herein lies the complexity of this. Who's going to issue out the certificates? Well, you have to have a certificate authority, which is a role on a Windows server internally, or use an external one. That entity is the one that issues out these certificates. Well, there's a whole lot of complicated stuff that goes along with that. You know, defining the certificate templates and setting up the auto enrollment and configuring the server and setting up revocation list and on and on and on and on. Okay? The chapters usually in the course on, say, Active Directory or Windows Server for certificates it's a long chapter because there's just a lot to do. And I don't mean to be going off on a rabbit trail. The point here is EFS just takes care of all that for you. If you go to encrypt a file, then there are going to be keys that are generated for you immediately. Those keys are going to be stored in a certificate. If there's no CA, then EFS just uses self-signed certificates. It just generates certificates on your behalf, and we'll see this here shortly. And so it does not require a CA. Now, if you're a member of the domain, you're logged on to Active Directory, and there is a CA that's linked into Active Directory, then EFS will obtain a certificate from the certificate authority. And that is better in multi-user type of environments. But if you just want to encrypt files, there isn't really any requirement. You check a box, EFS will generate a self-signed certificate, and that's where these keys will be stored. Okay? If you're using the self-signed certificate, it's difficult to share files with other users. If you're using certificates from a CA, that's certainly possible. And it's not impossible in the former scenario, but it's just much more difficult. So when a person goes to encrypt a file, there is going to be a particular process that is followed. First off, you can encrypt a file using File Explorer, or technically the Cypher.exe command line utility. I don't believe that Cypher is overly used unless you're trying to automate it or something, writing a script. But you do want to know that that one exists. We'll stick with File Explorer. You just go to the properties of a file and you get into the advanced settings on the general tab, and you're going to see that the checkbox to encrypt the contents right next to the checkbox that we saw for compression. When you do that, when you check that box, a certificate is going to be generated, self-generated, or obtained from a CA if there was a CA online. And that certificate contains a public-private key pair. The private key is actually stored outside of the certificate in the user profile, the local certificate store. The public key is in that certificate. But the point is that it is a pair, and as we said, with asymmetric encryption, whatever is encrypted with the public key can be decrypted with the private key, and vice versa. EFS behind the scenes is also going to generate another key, and this other key is called the file encryption key, right, or the FEK. Now that is a symmetric key. So EFS is a combination of public and private key cryptography. The actual key that's going to encrypt and decrypt the data is that file encryption key. So what EFS does is it protects access to the file encryption key using the user's public key. And so in the file header, like in the image that we see in what's called the data decryption field, or DDF, the file owner's public key is used to encrypt the file encryption key. And so when an authorized user comes and tries to access the file, it's detected that it's encrypted. It looks at the local certificate store for that user, finds a private key, applies the private key to the file header. If it's a match with the public key that was used to lock it down, then it unlocks the file encryption key, which decrypts the file. Okay, and so that happens automatically. Now, along with that key, an additional copy of the file encryption key is going to be generated, and it is going to be protected using the person we call the recovery agent, which is the administrator by default, using their certificate. Okay? The recovery agent certificate can be loaded in local policies, or it can be loaded up in group policy and defined. So every time a file is encrypted, it encrypts it with the end user's information, but it also encrypts a copy of the file encryption key with the recovery agent's certificate. And that way, a recovery agent can go and recover files, because you can have user profiles that get blown away, that get corrupted. You can have a user that leaves the company, you delete their account and their profile, and next thing you know, you realize they've encrypted some files. We want a way to get back that information. We have to be able to decrypt it. And so that is in the data recovery field. Now, incidentally, one more thing is that if you're sharing with other users, the whole way that you're able to do this is by doing essentially the same thing, encrypting another copy of the file encryption key with their public key. And so you're assuring that only somebody coming to the file with a private key that matches one of the public keys will actually be able to decrypt the data. There are some additional options that we have in Windows 10. One of those is that we've got up to 256-bit encryption using the advanced encryption standard now. That is really high encryption. This is a very tight security measure. Support also for the storage of private keys on smart cards, which would increase security, and it also makes it so that you can be sure to have access to your information. If you're encrypting stuff on a network share and then you're accessing from different computers, well, if you access from a computer that doesn't have your certificate on it, then you're not going to be able to decrypt. So it increases security and it gives you a little bit more mobility. There is an EFS rekeying wizard now. Some of these were introduced in Windows 8, and that allows you to migrate to new certificates. There are a whole ton of policy settings for EFS. and then offline files can be encrypted as well, and that's a per user encryption of those offline files. So there are some additional options that we have in Windows 10 if you plan to be using this, especially in a larger business environment. Okay, so let's take a look at how to go through this. We're going to just open up File Explorer. We'll go to my secondary storage here, and let's create a new folder. We'll call it Secret. And we're going to go to the properties of the folder, over to the Advanced tab, and check the box. Okay, it really is that simple. Now we're going to go into the MMC first here. So I'm going to set up the certificate snap-in for my user account. Okay, because I just want to see what I have here, and notice what I have is nothing. I don't have a certificate right now. Okay, but as soon as I hit OK and apply, then it should now generate a certificate for me. And there we go. Okay, so there's the administrator certificate issued by the administrator. So it's a self-signed certificate, and it is allowing data on the disk to be encrypted. And so that's what I meant by, transparent. It automatically generated that for me without me having to do anything. It does color code that folder so that we know that it's encrypted. And if I were to place any items inside that folder, and we'll just create an item, then those items are going to be encrypted as well. So when you save files into the folder, they're going to be encrypted. But notice I can just double click the file and open it up, and it's not going to stop me from doing that. It immediately decrypts it. I don't have to specify anything. It doesn't really take longer. I mean, it's a very seamless, transparent process, but this is an encrypted file. I'm not going to take the time to log out and create another account, log back in, but if I did that, then I wouldn't be able to access that from another account. So, that's the security. Now, can you see any more? Well, yes, you can go to the file and go into Advanced, Encrypt Contents. Now Details is lit up, and when you click on that, you can see our version of the data decryption field and the data recovery field. Okay, so this is the data decryption field. This is the certificate. Okay, and then this is the data recovery field because it's the recovery certificates. Notice it's the same account, I know, but it is a different certificate because this is actually the recovery agent certificate, and this is the one that was just self-generated when I said that I wanted to encrypt it. Okay, so and here's where you could add an additional user, and you could find a user and look in Active Directory. But it's at that point that it gets a little difficult if you're using self-signed certificates. So if you actually expect people to be using EFS for more than just their personal data, then you should make sure that you've got a certificate authority. Another thing to say is this is all based on user identity. Okay, so there are times when this is useful and there's times when it's not. And it does not eliminate the necessity of having a good password. Because if I can log on as you, then I am you to the system. And if I'm you, then I have access to your certificate as a part of the user profile, then I'm going to be able to decrypt files. Okay? Now there's another reason for the storage of the private key on a smart card. Because it's not actually on the physical computer, it's on a card that somebody has to have. As well as me accessing your files, using your account, but doing so from a different computer would not be successful because the certificate is installed locally on the system. So it is very secure. I just want to throw that out there. It is a lot of it's based on the user's identity. So if I can sit down at your computer and you've got a little Post-it note that tells me what your password is, and you've hidden it under the keyboard or in a drawer or something, I can get that information, then I can get all these encrypted files. So we just, part of that is just awareness of how this technology works. Okay, so let's click OK there. We can go into PowerShell here, and I'm just going to look at Cypher .exe. You're in a current directory there, so let me switch directories to ePrivate. I thought, oh, it wasn't called private though. It was called secret. There we go, eSecret. And then so we go cipher, and if you just want to go /?, you can see there are a ton of things here. You know, E to encrypt, D to decrypt. That's probably all you would need to know if you even see something in regards to this. C displays information about files. And so, you know, if I just type cipher, it says new files added to this directory will be encrypted. Okay? If I say cipher/C, then it's going to give me a little bit more information. Shows me the files there. Shows me who can decrypt them, the certificate thumbprint. It also shows me that I'm using AES 256-bit encryption. Okay? So cipher is a useful one, as I said, unless you're doing a lot of automated stuff, though. May not be using that. Let's just take a look at the policies. When we get into Windows setting, computer config, Windows settings, and then security settings, that is where we are going to find our settings for encryption. Under public key policies, you've got the encrypting file system. Okay, now, the same thing, actually, oh, you know what, that's in a GPO, I'm sorry. Okay, so this, and there's nothing defined right now. There would be something defined in the group policy objects. Basically, we can just go and add a recovery agent. I mean, that's what we would be wanting to do, specify who it is. Otherwise, the default admin is used. Okay. The other thing you can do here is go to the properties and say, we don't want to use this. You know, and that is fine if you don't want to use EFS and you don't want people encrypting files and whatnot. You can just go make that change. You would make that change in a group policy object, though not in the local policy. Okay. So EFS is great for data protection. It's not the only data protection, though. We also have full volume encryption that we'll talk about here in just a second using BitLocker.